Hello Year 12, we're just practicing empirical formula calculations. There's a few people have asked me to go through some questions from task 18, so I'm going to do that now. This is question 8 of task 18, which most of you did for homework and got right, but a few people struggled, and that's fine. So you're told the compound contains carbon and hydrogen and oxygen, carbon, hydrogen, oxygen. Let's see the question really, I guess, as well. This question's 8 from here, so I'll leave that there. If you need to make a note of it, you can do. I'll scan back down to here again. So you're told in the question, you've got 40 grams of carbon. So with the step A was write down the data, whatever data you're given. And in the question it said there's 40.0 grams of carbon. Just writing down the data, 6.7 grams of hydrogen and 53.5 grams of oxygen. You're told in the question, what else? It's got a molecular formula of 60. And we'll need that later on. You've been asked to find out the empirical formula and the molecular formula for this compound. So that's step A. Step B is to write down the relative mass of each of the elements. So 12 for carbon, 1 for hydrogen, and 16 for oxygen. And that, if you do A divided by B, or the mass divided by the AR, you get the number of moles, and we can work out the molar ratio for those elements in that compound. 40 divided by 12 is 3 1/3. You should write it out 3.33, but I'm being lazy. 6.667, I'll do it like that. Shouldn't really write recurring dots. And then 53.5 divided by 16 is 3.34. I'm taking these from elsewhere, I'm actually checking them in the calculator, so I'm trusting these are right. If you do step D then, which is work out the ratio as a whole number for carbon to hydrogen and oxygen, you simply divide by the smallest, so it's 1 to 2 to 1. Okay, so the empirical formula therefore is CH2O. Now to work out the molecular formula, we've got to look at the fact the molecular mass is 60, and the mass of this formula, so the MR of the empirical formula, is equal to 12, add 1, add 1, add 16. So 12, add 2, add 16, is equal to 30. And to work out the molecular formula, you do the molecular mass, which is 60, divided by the formula mass of the empirical formula, which is 30, is equal to 2. So there's twice as many carbons and hydrogens and oxygens there are in the empirical formula in the actual thing. So we go, the molecular formula must be C2H4O2. This just is the factor, how many times we've got to times all of these by to get the molecular formula. So the answer there for the molecular formula is that. Question 9 was a bit harder. Well done for working it out, those of you who did. I went through a method with you in class. I also sent you another video going through questions like this one. I'll just quickly put it on the screen there so you can see it, make a note of it, screenshot it if you need to. There is a mistake on here, I think it's 86 if I remember rightly, or 84, we'll have a look in a second. That's what we're going to be working out here. So this is a combustion analysis. You're told you've got carbon, hydrogen and oxygen in the molecule. You're going to burn it, and we're going to work out from the amount of carbon dioxide that's been produced what the empirical formula is. These are reasonably common questions and doable once you know how to do them. So you're told in the question that it's carbon, hydrogen and oxygen in the compound. We don't know the ratio. Call them X and Y if you like, and Z. Reacts with oxygen to give carbon dioxide and water in complete combustion. If you write underneath what you know to start with, it's usually a good place to start. We're told the compound, which we're calling X, we've got 0.43 grams of that stuff. We don't know how much oxygen it's reacted with, but we're told if you burn that stuff, you get 1.10 grams of carbon dioxide and 0.45 grams of water. So you can work out from there everything that you need. So what we need to do is work out first of all the number of moles of carbon dioxide. And to do that we do the mass divided by the formula mass, which I've just paused the video then, hopefully it didn't glitch too much, and you end up with 0.0917 moles. And from that, of course, you can deduce the number of moles of carbon. The number of moles of carbon is the same as the number of moles of carbon dioxide. It's also 0.0917 moles. We can also work out the number of moles of water by doing the mass of water, 0.45, divided by the MR. I should have shown how I worked this out. So this is 1.10 divided by 44. To work out the moles of water, you've got to do 0.45 divided by the formula mass of water, which is 18, and you end up with, and for that I got 0.025. But to work out the number of moles of hydrogen, we need to times that by 2, because there's twice as many hydrogens in water as there are hydrogens. There's 2 hydrogens per water. So the number of moles of hydrogen is 2 times that number. So 2 times 0.025 is equal to 0.05. Right, so we're getting there. Right, we need to know the mass of each of those elements as well. While I was doing that, I was just looking up and realised this is wrong. This is really annoying and embarrassing, so let's just change that. I can't bother to start the video again. Forgive me. 1.10 divided by 44, of course, comes to 0.025, which means the number of moles of carbon is also 0.025. Number of moles of water was also 0.025, so the number of moles of hydrogen, as we said, times by 2 is 0.05. Okay? We need to know the mass of carbon and the mass of hydrogen, and you're going to get that from multiplying the moles of hydrogen and the moles of carbon by their formula masses, in order that we can work out the mass of carbon and hydrogen in our compound. We know the total mass of the compound is 0.43 grams, so if we know the mass of the carbon and the hydrogen, we can take those away from 0.43, and that gives us the mass of oxygen. It allows us to work out the moles of oxygen. Okay, let's go ahead with that then. So the mass of carbon is equal to 0.025 times 12, which is equal to 0.3. And the mass of hydrogen is equal to 0.05 times 1, which is 0.05 grams. The mass of oxygen, therefore, is equal to the mass of the compound, which is 0.43, take away the mass of carbon and take away the mass of the hydrogen. Right. And that comes to 0.08 grams. And so that means we can work out the moles of oxygen. So we're getting there now. So the number of moles of oxygen is equal to 0.08 divided by 16, which is 0.005 moles. So the ratio of moles in this compound, then we now know the ratio of moles. So we've got carbon 0.025, hydrogen 0.05, and oxygen 0.05, right? So the molar ratio, therefore, is, divide them all by the smallest one, which is this one. So it's a 1 to 10 to 5 ratio, so it's C5, H10, O. That's the empirical formula. That gets you part of the way there. If you work out the formula mass of that empirical formula, you do 5 lots of 12 for carbon, add the 10 hydrogens, 1 each, and the oxygen, you get 86. And so that must also be, given that's the formula mass of the compound, I think there's a little mistake in the question, it says 85, but the answer there is 86. So that is the empirical formula and the molecular formula. To show that in an exam, you do 86 divided by 86, which would be in the question if it wasn't a mistake, is equal to 1. So that means empirical formula equals molecular formula. That's a little R with a line under it, was equal to C5H10O. So you just show the examiner everything you know along the way. Question 10 is, what I remember, I haven't done it for a while, but a little bit harder. So let's just go through question 10 now. If you were struggling with that one and wanted to have a go at it. So this I feel like is a little bit beyond the scope of what you have to do for IB. It's a nice challenge for you. So we've got ammonium dichromate, and you add it gradually to something called ammonium thiocyanate, and you get this salt formed, okay? The formula you're told is NH4 bracket Cr SCM, we don't know how many, and then NH3, we don't know how many, square close brackets, all right? There's lots going on there. You have to try to work out the formula of this compound based on the information given. So we're just going to go through the approach that we've been taught here. So we're told that the chromium, so write down what we know. So step A, chromium is 15.5%. The sulfur is 38.15%, and the nitrogen is 29.2%. There is, of course, hydrogen present as well, but you don't need to know about the hydrogen to solve this puzzle. So you might have worked it out with hydrogen as well, working out the remainder. Okay, so if you divide those by the atomic masses for each of them, so chromium is 52, sulfur's 32.1, nitrogen 14, you get these numbers. So 15.5, that and that. So it doesn't matter whether it's percentages or mass, percentage by mass, you do the same approach and you get the molar ratio, which is 0.298, 1.19, that divided by that's 1.19, that divided by that is 2.09. So this is the ratio of those elements in that compound, but not as a whole number. So to get them as whole numbers, you divide by the smallest number, which is this one. So divide them all by 0.298. That will give us a 1 to roughly 4, I think it's 3.99 to 7.01, but we'll call it 7. Nice whole number ratio there. Okay, so we know the ratio of chromium to sulfur to nitrogen, and that's, you should be able to get to that point using exactly the method that I've taught you so far. So you can then really solve it just by working it through. Let me show you how to do that. And it's really not overly challenging, provided you start with the point of view that chromium is 1. Okay, so there's 1 chromium, and the only place you find sulfur in the compound is in the SCN there. So X has to be 4. There must be 4 SCNs in that molecule, that substance. And so there must be 7 nitrogens. We've already taken up 4 of those nitrogens there and 1 there. So there must be 2 ammoniums, 2 ammonias there. So Y must be 2. It's the only possible combination where you've got 1 to 4 sulfurs to 7 nitrogens. And so the answer is X4 and Y is 2. And I hope that was useful. And sorry about the mistake from the first question. These things happen.